Hello everyone, we are solving problem number 853 car fleet. So this is a very interesting problem. Let's check out the problem statement. So there are n cars going in the same destination along a one lane road. The destination is target miles away. Okay, you are given two integers array position and speed, both of length n, where position of I is denoting the position of ith car while speed is denoting speed of that car in miles per hour. A car never passes another car ahead of it, but it can catch up to it and drive bumper to bumper at the same speed. The faster car will slow down to match slower car's speed, and the distance between these two cars is ignored. The car fleet is some non-empty set of cars driving at the position and same speed. Note that the single car is also a car fleet. If a car catches up to a car fleet at right at the destination point, it will still be considered as one of car fleet. So we have to return number of car fleets that will arrive at the destination. So it is a big problem statement and a very interesting problem. So what they are saying is, we have initial positions of all the cars and their speeds. So we have to find number of groups the cars going to form when they are going to be arriving at target. So groups means, suppose two cars, I will explain it here. Okay, so this is one car and this is another car. So let's say this car has original position 0 comma 0 and speed of, let's say, 5 meter per second, while this car has position of, let's say, 2 comma 0 and speed of 2 meter per second, and they are going in this direction. And let's suppose our destination is here around, I will just write coordinates of destination also. So let's say destination coordinates of destination are 10 comma 0, suppose. So if you can see, this car with the 5 meter per second speed, which is behind the other car with 2 meter per second speed, is gonna catch up to that car sooner or later. But as we have given, we only have a where is it? Okay, so this is a one lane road, so no car can overtake other car or pass it. And for that condition, they have mentioned that if both cars are matching their speed, or if some car caught up to other car, they will run bumper to bumper at same speed, while faster car will slow down to match slower car speed. So here, as you can see, let's suppose after 1 second, coordinates of this car is gonna be what? So I will just mention it here. So coordinates after 1 second are gonna be 4 comma 0, and logically coordinates of this car with 5 meter per second 5 meter per second should be 5 comma 0. But as this is a single lane road, this car can never pass the car which is in front of it. So what are gonna be the coordinates of this car after 4 seconds? So this car also gonna have coordinates 4 comma 0, as it will catch up to this car, but it can't overtake it due to single rate road, so they will travel together. So what can we conclude from here? The car which is in front from the starting position is always gonna be in the front till the end, as no car can overtake it. So this is our first conclusion. So I will just write down here, no car can overtake other car. So that means initial positions, or let's say relative positions, are gonna be same. right? So what we can do, so now let's say speed of this car, I will say, okay, so let's say it is 2.5. So both cars will arrive at, how to write it here, okay, 5,0, and here again it is gonna be 5,0 after 2 seconds. Okay, so this car will be at 5,0 coordinate after 2 seconds, while this car is also gonna be there, as it is expected to have 10,0 position, but as it can't overtake the car which is in front of it, so it will be traveling alongside that car. So can we say these two cars are gonna arrive at our destination at the same time as a fleet? Yes, as this car has greater speed, so it will catch up to this car, and after that they will travel alongside. So what we can do, we will explain here also. Okay, so if the case is reverse, so let's say this car is in front of this car, and let's ignore these coordinates. Okay, so let's make it 0,0. So now can the car with 2.5 meter second speed overtake the or match up to speed with the car of speed having speed of 5 meter per second? No, as this car has better speed, so it will arrive first in the 2 seconds, while this car will take 4 seconds to arrive there. So these two cars are never gonna be in a fleet with these speeds. So what we can conclude, if car coming from back has greater speed and can catch up to the current car, then they will make a fleet, right? As they will travel together. But other case, if car coming from back has less speed, it can't form a fleet with car in front of him. It, okay, car in front of it. So what are going to be the crucial parameters for solving this problem? So as we have discussed the initial position, and we can see we can uh, manage them on their arriving times. So as in the previous case, the car which is in so it was like this. Okay, and let's say it is 2. Okay, so the uh, car which is in front is gonna arrive at 4 seconds, while car which is at the second position can arrive in 2 seconds, but it cannot overtake this car, so it is gonna be arriving there at 4 seconds as well. So we can conclude that if the car which is behind some car and has more speed than the more speed, or let's say less arriving time than the car which is in front of it, so it will form a fleet. So we will just make that point here as well. If car coming from back has less arriving time, then it will form a fleet with car in front of it. So that's all. Now we can solve this problem. So what we are going to do is, we will just make one class called car, and what that class is gonna have. So initial position and initial let's say speed. So let's make constructor. Let's say car int v int s this dot position is equal to p, while this dot speed is equal to s. Okay, so now we can make this array. Let's say cars new int, and I will just declare one variable for length, which is let's say position or speed dot length. You can use anything length, right? So let's run one loop and we will add all the car objects in our car array. So let's say car is equal to new car, and we will take position of that car and speed of that current car. Okay, and we will just push or add this object in our cars array. So after that we have to sort this array according to initial position. As we have already discussed, the car with positions ahead are always gonna be ahead, as no car can overtake them. So but we cannot directly sort this class or the object. So for that we are going to need comparable interface. Implement comparable with car. So not implement, is implements. Okay, and we have to make one compare to function. So let's say car other. So on what basis we are going to sort those cars? So let's just return this dot position minus other dot position, right? So now we can just say arrays dot sort cars, right? And now what we are going to do? So we should have sorted it in descending order, but it's okay, we will travel from last index to first index, so it's not a big deal. So now what we have to do, we are gonna need time variables for all the cars, as the arriving time is gonna be crucial, as if the car which is in second position has less arriving time than the car which is in front of it, so it means this car is gonna catch up to this car at some point, and they are going to form a fleet. So we have to keep track of arriving times of the car which is in front. So we will do it using stack. So, so, so let's say this is a stack. So if these two cars are forming the fleet, suppose we have confirmed that these two cars are forming the fleet, but how we can check if the car which is in third place can also form a fleet or not? So we have to keep track of arriving time from one of those cars. So which arriving time we are going to store in our stack or push in our stack? The car with less arriving time or the more arriving time? So definitely we are going to store the arriving time which is greater, as the car with less arriving time is gonna join the car with more arriving time, and they are going to form fleet, and they will arrive at the same time with this lesser speed, or the that more arriving time. So we have to keep track of arriving time which is in the front, as they cannot pass each other, so the sequence of reaching them is gonna be same. So let's make one stack, and we have to make it double, as we have to find time by using position and speed. And while integral values can't help, suppose this car is having arriving time 2.3 seconds, and some car is having arriving time, let's say 2.5 seconds, but due to integral values they are going to both store 2 seconds, so we don't want that. So for that we will use double, and it will be useful for storing the exact value. So let's make this stack, and now what we are going to do, we are just going to run a loop from last index, as we have sorted this array based on smaller position to larger position, so we have to travel from the last index to first index. So is greater than equal 0 and I minus minus, and what we have to do, we will just say speed is equal to our current car speed, and the distance or position whatever, so let's say dist car I dot position, right? Okay, so now we can find arrival time as, so as we have studied, speed is equal to distance upon time. So if we change that equation to for finding time, so it will be distance upon speed. So we can do this, we are multiplying it with 1d to convert it into double, and let's say also I did reverse distance upon speed into 1d, right? And we can just check if our stack is empty or not. So if our stack is not empty, so we will compare our current arrival time of our current car to the arrival time which is at the peak index of our stack. So we will check if this arrival time is greater than the stack dot peak. Why we are saying greater? So I will just give you one more example. So let's say this is the car, and it has, let's say, arrival time of 2 seconds. Then let's say time, let's say 5 seconds, and here if you can say arrival time of 3 seconds, right? So this car which is in front of all the cars having has 2-second arrival time, while the car which is in middle has 5-second arrival time. So this car with 5-second arrival time can never catch this car, as it will uh, reach to the destination 3 seconds earlier than this car. But the car which is in the last position has 3 seconds arrival time, so this car will definitely catch up to this car, but as it will not overtake this car, but it will form a fleet with this car. So if we find any condition where our current arrival time is greater than the arrival time of uh, car which is present in our stack, or let's say which is in front of our current car, so it will never catch up to that car. So our current border, or let's say the car which is gonna be barrier for the previous car, is gonna be the our car with lesser arrival time. Okay, as the previous cars cannot overtake this car if they have more or equal arrival time. So exactly, so in this case what we are going to do, we are going to pop our current the car present in our stack, as it is gonna be unchanged, untouchable from the car which is in which is behind, as it has more arrival time. So it will uh, they they both cannot form a fleet together. And our new barrier, or let's say car which is in front of all the cars remaining, is gonna be our current car, as it has more arrival time. So if we are getting this condition, that means we are getting new fleet, as this car is gonna reach sooner, and after that this group of cars is gonna arrive. So at that we have to make one variable. Okay, let's say 0, let's say 1, as there should be at least one fleet when even all cars come together. So we will increase our fleet if we get this condition. And else what we are going to do, else if let's have one more condition, if our stack is empty, then we don't need to check anything, we will just push our current car. So we will push arrival time. Okay, and in the end we can just return fleets. So I hope you understood this code. So let's try to run this. Okay, new, it should be car. Okay, speed, so I have to make it velocity, as we already have speed variable, so we have to change it, and let's paste it here. Okay, so now let's try to run this. Okay, why we are getting the error, let's check out. So okay, this distance should not be the position, we have to find arrival time, right? So for that we need distance we have to travel, so it will be target minus car's position, right? And we'll check if we have more errors. So compare to, okay, this will do. Okay, they are running, let's try to submit it. Okay, so I will just explain it once again. So what we have checked, so the car which is in front of all the cars is always gonna arrive first, as no car can overtake that car. So we made our first conclusion, as if the no car can overtake other car, as initial relative positions are gonna be same, as it is a single lane road. So our next conclusion is what, if car moving from back has greater speed and it can catch up to current car, and if it can catch up to current car, so they will make a fleet, as they are going to move bumper to bumper, as they have mentioned, while our faster car will slow down to match the car which is in front of it. And if the car coming from back has less speed, it can't form a fleet, as we have discussed with this example. The car which is in front of this car has lesser arrival time, so uh, it will reach to destination sooner than 3 seconds sooner than a car with 5 seconds arrival time. So they can't make a fleet while having this arrival times. So, and we have checked one more condition, if the car uh, which is in last position and it has less arrival time, but it will uh, it will reach the destination with the speed of car which is in front of it, as it can never cross it. So like this, for that we have made one custom class of cars for comparing initial positions, and we have sorted them in ascending order. So for that we have to run our loop from last index to first index, as the position which is in the rightmost position is gonna arrive first. So, and we also made one stack to keep track of arrival times of the car which is next. And when when two or more cars are forming fleet, we have considered time of arrival time which is lowest, as uh, all the cars are gonna travel with the speed of car which is in front of them. So we have checked that condition here, and if stack is empty, that means there is no car, we have to push our current arrival time. And we have increased our fleets if we get this condition where our arrival time of current car is more than the car which is present in stack. So thank you.